So, if you are feeling stuck with the Earth's energy budget worksheet and you need help, then this is the video for you. First, let's read the introduction. It says, in simplest terms possible, what is the Earth's energy budget? It says, the budget describes the balance between the radiant energy that reaches Earth from the sun and the energy that flows from Earth back to outer space. If we think about it, if we had 100% of the sun's solar energy coming and hitting us all the time, we probably would not survive. Okay, so this is important to our survival in the long run that we don't actually get 100% of the sun coming at us. It says that energy from the sun is mostly in the visible portion of the electromagnetic spectrum. About 30% of the sun's incoming energy is reflected back to space by things such as clouds, atmospheric molecules, tiny suspended particles called aerosols, and also the Earth's surface, including land, snow, and ice. The Earth system also emits thermal radiant energy to space, mainly in the infrared part of the spectrum. The intensity of thermal emission from a surface depends on its temperature. So things that are hotter would emit more thermal energy. Things that are cooler would not emit as much. So knowing that that's kind of what the budget is about, this balance between energy coming in and energy going out, we are going to look at this diagram here to answer a few questions. Now, I'm not actually going to go through all of the questions here. I'm simply going to go through the diagram. I'm going to make my screen a little bit bigger so we can see it really well. 150 looks good. Awesome. Let me close off that too. There we go. Okay, so this big circular part in the left-hand corner that represents the sun, and notice that this big chunky arrow coming down towards Earth's surface represents 100% of that solar energy. Okay, so all of the energy that comes from the sun is represented by this arrow. Notice that parts of the arrow are broken off though. There's parts that are being reflected by the atmosphere. There are parts that are reflected by clouds. There's a small part that's reflected from Earth's surface. There's even arrows here where part of that solar energy is absorbed by the atmosphere, and a little tiny bit of it is absorbed by clouds, right? So of that 100%, some of it is being reflected by the atmosphere, some of it is reflected by clouds, some of it is reflected by Earth's surface. If we total those together, that would tell us how much energy in total is being reflected before it even hits Earth's surface. These other two arrows tell us, if we were to add them together, would tell us the total amount that's being absorbed by the atmosphere and the clouds. And then look down below, I have to scroll down a little bit. There's even this like remainder of that arrow that represents radiation being absorbed by the land and the ocean. So there's 3 scenarios where this solar energy is being absorbed by things. Okay, so 3 scenarios where it's being reflected, 3 scenarios where it's being absorbed. If we were to add all of those together, it would equal 100%. Now, the Earth itself becomes heated, right? And we said that, even the back of the Earthship house, right, that dirt clump in the back, can radiate heat itself once it becomes heated. The Earth does the exact same thing. If it's absorbing some of this energy, it warms up and it wants to give off some of its energy. It's too hot, right? That's part of the balance there. So look at these arrows here. We're not going to focus too much on these smaller little bits, but things to be aware of. There is conduction and rising air. That's where we talked about, you look at a pavement and you see the heated air right above it. That's conduction, right? We also have thermal energy that's carried to the clouds and atmosphere by latent heat and water vapor. So water that's in ponds and lakes, as it gains thermal energy because it's being heated, it will eventually evaporate and head upwards towards the clouds. So some of the thermal energy is carried that way. There's also some radiation absorbed by the atmosphere. And then these 2 arrows here, what we're going to really focus on, a big chunk of the radiation from Earth's surface is just going to go straight to the space from clouds in the atmosphere. The other chunk, the 6% here, radiated directly to space from Earth, okay? So whether it's radiated from the clouds, whether it's radiated directly from the Earth, either way, this radiation is going straight back to outer space where it's just going to go and do its thing out there, all right? So hopefully that helps you answer some of those questions. The very last question is going to ask you to write a summary paragraph that compares the Earthship house to Earth. Things that you could be focusing on is radiation, meaning what's coming in, where might it be reflected? Where would it be absorbed? If it is absorbed, how can it be dispersed throughout the house? And how does that excess heat get radiated away from the house if it is too hot? So again, hopefully that helps. If you do need extra help, then email me or come to office hours.